Right, ma. Morning, all of you. Today we are discussing LCM and HCF. LCM and HCF. Today we are discussing LCM and HCF. Okay, na? Right, ma. Now, first of all, we'll talk about LCM. Right. Now, first of all, we'll talk about LCM. LCM. Basically, what is the meaning of LCM here? Least common multiple. Least common multiple. LCM. Least common multiple. Okay, now least common multiple. Least common multiple. LCM. Least common multiple. Now, for example, 2, 3. Two numbers are there, but 2, 3, two numbers are there. For that, if you wanted to find the LCM, for that, if you want to find the LCM, first of all, we have to know that what is the basic method, basic method. Okay, now, as per the full form, least common multiple. As per full form, first of all, we should write multiples, multiples. Basically, what is the meaning of multiple? Multiple is nothing but simply table, table. That means multiples of 2 multiples of 2, multiples of 2 nothing but two table numbers 2, 4, 6, 8, 10, 12, 14, 16, such kind right now next multiples of 3, multiples of 3 nothing but three table numbers 3, 6, 9, 12, 15, 18, so on. So on. Right, ma? As per full form, first of all, we should write multiples. Multiples is nothing but table. Okay, now we wrote the multiples of 2 as well as we wrote the multiples of 3. From that multiples, we should select common. Common. Observe in both cases, what are the common there? What are the common? Okay, now common. What are the common observe in both cases? What are the common observe 6 is common. 6 if you continue again, what is common 12. 12 if you continue, you will get some more. That means among that, what are the common 6, 12, you will get some more. Some more. From that common from that common, we should select least least. What is the least one among this 6? So least is 6. So nothing but LCM is 6 LCM is 6 It is very basic method We have to know that before going to the problems we have to know that it is clear So LCM full form least common multiple. As per full form, first of all we should write multiples. From that multiples we should select common. From that common we should select least It is a very basic and general method. We will not use, but we have to know that right now. For example, if you wanted to find the LCM for this 2, 3, 4, 6, 8, 12. For example, if you wanted to find the LCM of these numbers 2, 3, 4, 6, 8, 12, shall you see how to find okay now in school level already we learned generally always we should take the prime numbers prime numbers what are the prime numbers 2, 3, 5 which are divisible by 1 and itself 2, 3, 5, 7 such kind okay what is the first prime number 2? Right, what is first prime number 2? Now in 2 table 2 ones, 3 we can't get so 3 as it is, 2 twos, 2 3s, 2 4s, 2 6 ma, 2 6. Okay now. Now again, which table we can take ma? We can take ma again ma 2 table. In 2 table we again will get ma 2 and 4 ma such kind. So again we can take ma 2 table. Okay now. Now 1 we can't get, 3 we can't get, 2 ones, 3 we can't get, 2 twos, 2 threes ma. Okay now. Right ma. Now next which table we can take ma? We can take ma 2 table. 1 3 3 1 3. Okay ma. Next we can table ma 3 1 1 1 1 1 1. Okay now. Now what is the LCM ma? We'll multiply all this ma. 2 twos are 4, 4 twos are 8, 8 threes are 24. So what is the LCM ma? 24. LCM ma 24. It is my very general method ma. We learned in school maths also ma. Always ma we should prefer ma prime numbers. Prime numbers. Okay ma. Now other than this ma, now we are moving to shortcut ma. Shortcut. Okay now. Now 2, 3, 4, 6, 8, 12. I am taking my same numbers. What are the numbers I am taken earlier ma? I am taking my same numbers ma. 2, 3, 4, 6, 8, 12. Now by through shortcut ma, through shortcut, how can we find? Shall we see ma? Through shortcut ma. Okay now. Now what is the first number ma? 2. What is the first number ma? 2. Observe ma. In 2 table ma. In 2 table, are you getting any numbers among this ma? Among that ma, if you are getting any numbers in 2 table, if you are getting any numbers ma, such can we can eliminate ma. We can eliminate ma. Observe carefully ma. In 2 table, what you will get ma? In 2 table, what you will get ma? 4 you will get, 6 you will get, 8, 12. So that's why we can eliminate the 2. Okay now. If you're in 2 table ma, if you are getting any one ma, so we can eliminate the 2 ma. We can eliminate the 2. Now next ma, 3 ma. In 3 table, can you get any one of these ma? 6 as well as 12 is there. So we can eliminate the 3. In that table, if you are getting any one, at least one term is there, we can eliminate such kind. Okay now. Now in 4 table ma, we'll get ma 8 as well as ma 12. So we can eliminate the 4 also. In 6 table ma, we'll get the 12. So we can eliminate the 6 also. What is the next number ma? 8. In 8 table ma, we can't get anyone, so we cannot eliminate the 8. We can't eliminate the 8. What is the next number ma? 12. In 12 table also we can't get anyone ma, so we can't eliminate the 12. After elimination ma, finally what are the numbers are balanced ma? 8 and 12. Whatever the numbers are balanced ma, for those only we need to find the LCM. No need to find for all numbers ma. After elimination, whatever the numbers are balanced, for those only we should find the LCM. Now take the LCM for these two ma. 2 4s are 2 6. Next ma, 2 2s, 2 3s. Still we can't continue ma. We can't get ma. So 2 2s are 4, 4 2s are 8, 8 3s are 24. Same answer ma, 24. Normal ma, it is a shortcut. After elimination, whatever the numbers are balanced ma, for those only we need to find the LCM. No need to find for all numbers ma. Whatever balanced ma, for those only we should find the LCM. Okay na? Right ma. Shall we see no ma? One more example ma. Now, for example, we'll see one more ma. 4, 6, 8, 12, 48, 16, 24, 2. If you want to find the LCM of these numbers ma. If you want to find the LCM of these numbers, observe carefully ma. 4 can we eliminate or not ma? Okay now. In 4 table we'll get ma 8 to 12, 40. At least one year getting ma, we can eliminate. 4 we can eliminate as well as ma 6 also we can eliminate, because in 6 table ma 12, 48 such can you will get ma 6. 8 also we can eliminate, because 8 table ma you will get ma 48, 16 such kind. So we can eliminate the 8. We can eliminate 12 also, because in 12 table we will get ma 48 ma. 48 ma. 48 we cannot eliminate ma. We cannot, because in 48 table ma you will not get any one number ma. So we can't eliminate the 48. Okay na? Next ma 16 ma. 16 we can eliminate, because in 16 table ma you will get the 48. So we can eliminate the 16. Next ma 24. In 24 table we will get ma 48. So we can eliminate the 24 also. 2 clearly we can eliminate ma. So what is the number is balanced ma? 48. If only one number is balanced ma, that is only the LCM. So LCM ma. LCM is how much ma? 48. If only one number is balanced, ma, that is only the LCM. Ma. No need to find for. No need to find. Ma. Is it clear? Ma? After elimination, if only one number is balanced, that is only the LCM. In case two or three numbers are balanced, ma, first we need to find the LCM. Ma. And this elimination, ma, not only in initial step, ma, we can eliminate any step. Ma. We can eliminate ma, any step. Ma. For example, ma, for example, you are doing a problem like this. Ma. You are doing the problem in this way. Somewhere you got, let us assume, 3, 6, 9. You got in this way. Okay, now observe carefully, ma. Here, what we can eliminate, ma? We can eliminate the 3. That elimination, ma, not only in initial step, we can eliminate ma anywhere in any step of the problem. We can eliminate in first step, second step, third step, fourth step. At any step, ma, we can eliminate ma. If it is there, we can eliminate any one step. Right. And one more thing, ma, elimination maybe will be there, may not be will be there, ma. That is depends upon the numbers. Whatever the numbers are there, ma, based on that numbers, ma, maybe may not be, ma. Okay, na? Is it here, ma? Right. It is ma one kind of shortcut. Elimination is one kind of shortcut. And one more shortcut is there, ma. Shall we see now, ma? What is the one more shortcut? Ma? Okay, now, for example, 6, 8, 12. These numbers are there, ma. 6, 8, 12. Ma. Now we are moving ma second shortcut. Ma. First shortcut is elimination. Now we are moving to second shortcut. Ma. Second shortcut. What is the second shortcut? Shall we see now, ma? 6, 8, 12 is there, ma. If you wanted to find the LCM of these numbers, among that numbers, ma, what is the highest number, ma? 12. Highest number is 12. Now we are looking ma second shortcut. Ma. Second shortcut. Okay, now what is the highest number, ma? 12. Now observe carefully, ma. In balanced numbers, if you are getting 12, that is only the LCM. In 6 table, we'll get the 12 clear. In 8 table, ma, can you get the 12, ma? No, so we can't get. That's why 12 is not LCM. When 12 is not LCM, go for the next multiple of highest number. Go to the next multiple for highest number, ma. 12 table, next multiple, ma. 12 ones are 12. 12 to so much, ma? 24. 24. Observe, ma. In 6 table, can you get 24, ma? Clearly 4 times. In 8 table, can you get 24, ma? Clearly 3 times. We are getting ma 24 is clearly in 6 table as well as ma 8 table. So what is the LCM, ma? 24. LCM is 24. It is ma second kind of shortcut. Okay, ma. What I am doing, ma? First of all, see the highest number. The highest number, if you are getting in another number tables, that is clear. If not, go for the next multiple, ma. Next multiple. Okay, na? We'll see one more, ma. For example, ma, 10, 20, 30. Such kind is there. 10, 20, 30. Ma. If you wanted to find the LCM of these numbers, ma, what is the higher number, ma? 30. 30, ma, will get in 10 table. Okay. Will not get 20 table, ma. So 30 is not the LCM. 30 is not the LCM. Then we should go the next multiple of 30, ma. Next multiple of 30. What is the next multiple of 30, ma? 31 is 30. 32 is 60. 60. Observe, ma. 60 can we get in 10 table, ma? Clearly 6 times. In 20 table, ma? Clearly 3 times. So what is the LCM, ma? 60, ma. LCM is 60. 60. Is it clear, ma? Now I said, ma, normal method, elimination method, as well as ma, by looking the highest number, ma. 3 methods, ma. So based on the numbers, ma, you can choose your convenient method, ma. You can use normal method or elimination method, or by looking the highest numbers, ma. Not which method is not compulsory, ma. Based on the numbers, you have to decide which is convenient for you, ma. Okay, now. Now we are looking, ma, find the LCM of 16, 24, 48, 96, ma. 16, 24, 48. Now you can choose your convenient method, ma. We can use normal traditional method or elimination method or by looking highest number. Now I am going, ma, through elimination, ma, based on your convenient method, ma. Okay, now for the first question, ma. For the first question, I am looking, ma, elimination, ma. Elimination. Okay, now what is the first number, ma? 16. Observe, in 16 table, ma. In 16 table, can you get any one of this, ma? We'll get 48 as well as we'll get the 96, ma. That's why we can eliminate the 16. Eliminate the 16. That is clear. Okay, what is the next number, ma? 24. In 24, can you get anyone, ma? Right, ma. 24, can you get anyone, ma? 48 clear, 96. So 24 also we can eliminate, as well as, ma, 48 also we can eliminate. What is the balance ma? 96. That's why what is the LCM ma? 96. So your answer is ma 96. 96 is your answer. Right ma. Now try these questions ma. Try this second, third, fourth ma. Try that ma. Once try that ma. Second, third and fourth. You can use your choice method ma. You can use normal or elimination or by looking highest number. You can use any one method ma. Now try that three questions ma. Right ma. Now we'll see about ma second question ma. Second ma. 6, 9, 12, 15 ma. 6, 9, 12, 15. Now by looking through elimination ma, what we can eliminate ma? 6 can we eliminate or not ma? Clearly, because in 6 table we'll get the 12. 6 we can eliminate. 9 we can't eliminate. 12 we can't eliminate. 15 we can't eliminate. Okay now? Now I'm going through normal. What are the numbers are balanced? 9, 12, 15. Okay now? 9, 12, 15. 9, 12 and 15. Now 9, 12, 15 ma will know clearly in which table ma? 3 table. 3s, 4s, 5s. 3s, 4s, 5s ma. Okay now still no more table la. So what is the LCM ma? 5 4s are 20, 23s are 60, 63 so much for 63 is 180, 180. So what is the LCM ma? 180, 180. Is it clear ma? So first of all I used the elimination ma. By using the elimination ma, I eliminated 6 number. But the balance numbers ma 9, 12, 15. For those I am taking the normal number ma. 3 3s, 3 4, 3 5s. We can't eliminate anyone ma. 5 4, 20, 23, 60, 63 is ma 180, 180. Okay ma. Now right ma 180. Now we are going to next ma thought. Now observe carefully ma 18, 24, 30 ma 18, 24, 30. Can you eliminate anyone ma? We can't eliminate anyone. So by looking by looking highest number also you can use, or you can use my normal method ma. Now I am taking my based on your convenient ma. This method is not mandatory, that method is not mandatory. Based on your convenient ma. 18, 24, 30 is there ma. So for 18, 24, 30. Now here 18 we can't eliminate, 24 we can't eliminate, 30 we can't eliminate. Now I am moving ma through general method ma, general ma. So if you observe carefully ma, 18, 24, 30, all you will get in 6 table ma. Actually 6 is not the prime ma, 6 is not the prime, but we can take 6 because you will get all the numbers in 6 table. That's why we can take ma. If you are reading all numbers in any one particular table, we can take. If it is prime or not prime, we can take. Okay now 6 3s, 4s, 5. Still no more continuation ma. We can't get 3 4 5 in one table. So what is the LCM ma? 5 4s are 20, 23s ma 60, 66 are how much ma? 360. LCM ma 360. LCM ma right ma 360, 360. Right ma 360. Okay now we are going to next example ma. Now 12, 15, 20 ma. 12 we can't eliminate, 15 we can't eliminate. You can go through normal method, or you can go through highest number by looking highest ma. Now I am looking ma by highest number ma, by highest. 12, 20 we can't get in 12 table, we can't get in 15 table. Okay now? And now in 20 table, next multiple is how much ma? 22 is ma 40. 22 is 40 also we can't get in 12 table, we can't get in 50 table. So go for next multiple. In 20 table, 23, so much 60. 12 table clearly 5 times. 15 table clearly 4 times. So what is the LCM? 60. So answer 60. 60 60. Okay now. Now I shown for you three measures: normal, elimination, as well as by looking highest number. Based on the numbers, you have to use your convenient method. Is it clear? So what is LCM? 60. Now I shown for normal numbers. Here totally we are having four cases. Four cases. One is for normal numbers, next for decimals, next for power numbers, next for fractions. In four cases, we'll observe LCM as well as HCF. Normal numbers, decimal numbers, power numbers, as well as fractions. Now I shown for normal numbers. Now we are moving decimal numbers. When decimal numbers, how to find the LCM? Okay, now find the LCM of 0.1, 0.01, 0.001, 0.0001. Now we are looking first question. Okay, now first I will show here 0.1, 0.01, 0.001, 0.0001. Okay, now observe carefully 0.1, 0.01, 0.001, 0.001. Here your first step is observe carefully. After point maximum how many numbers are there? After point maximum how many numbers? Here one number, two numbers, three numbers, four numbers. Maximum how many numbers? Four numbers. First, that is we should observe. Maximum four numbers are there. That's why first of all make all are four numbers. Make all are four numbers. To make wherever less, there we should write the zeros. Wherever less there we should write the zeros. First of all make all as a four numbers. Wherever less, there we should write the zeros. Now shall we see no? After point only one number. To make four, we should write how many zeros? Three zeros. 1, 2, 3. Okay, now next number 0.01. Here also we need to make four. To make the four, already two numbers are there. We should write how many zeros? Two more zeros. Okay, now it is 0.00. Already three digits are there. To make the four, we should write 1 0. Okay, it is clearly 4, no need to do anything. Now observe all became 4 4. Here also 4 4 4 4. After point all became 4 4. Whenever all becomes equal, then we can cancel the point. We can remove the point. Point we can remove. Point we can remove. We can remove the point. We can remove the point. We can remove the point. If you remove the points, what is the number balance here? 1000. Here this for these zeros no value 100. Here 10. Here 1. Okay. Now normal numbers are came for us normal numbers, actually point numbers, but by doing in such a way we got all normal numbers. Whenever normal numbers I shown normal method, elimination method, by looking highest number. You can use your wish. I am looking elimination method. Elimination. In 1000 table we can't get anyone, so we cannot eliminate the 1000. 100 we can clearly eliminate because in 100 table we will get the 1000. 10 we can eliminate clearly because in 10 table we will get 1000. 1 we can eliminate because in one table you will get all numbers for 1. So what is the balance? 1000. So our LCM is 1000. But 1000 when it is 1000 whenever normal numbers are there, then 1000 is your answer. But for us not normal numbers all are decimal numbers How you remove the point? Again put back the point in such a way How you remove the point or put back the point? We remove the point after 4 digits. So again keep the point after 4 digits as it is. 1, 2, 3, 4. Put the point. So what is the answer? 0.100 means 0.1. Answer is ma 0.1 ma. Answer is ma 0.1. Is it clear ma? First of all, what I said ma. First of all, look that after point maximum how many numbers are there. Okay na? And make all that in such a way ma. Wherever less ma, there we should write the zeros. After doing of that ma, remove the point. Whatever the normal numbers will balance ma, for that find the LCM. For that LCM ma, again how you remove the point, again put back the point in such a way. Okay na ma? Is it clear? Now once try this ma. Second, once try this ma. Second question ma. Now, shall see now ma. Now we are looking ma second question. Second question. Point to 2, point 0 to 2.0 ma. Point to 2, point 0 to 2.0. Observe ma after point maximum how many numbers are there? Here one number, here two numbers, here ma one number. Maximum one numbers are there ma two numbers. So first of all make all as a two numbers ma. Wherever less ma there we should write the zeros. So it is ma 0.20. It is ma clearly two numbers ma no problem at all. It is ma 2.00. Now all are became ma two numbers. Let ma two one answer is two ma. Shall you see now? So all became two numbers. So we can remove the point. Point remove the point, remove the, but the number balance ma 20 to 200. Now numbers are became normal ma normal. Now we can find the LCM ma. You can use any one method ma. Now 20 we can eliminate clearly. 2 we can eliminate. So what is the LCM ma 200. LCM 200. But we should put the back the point after how many numbers ma 2 digits. So 2.00. 2.00 nothing but how much ma 2. Answer is ma right ma 2 ma. Answer is 2 clearly ma. Okay na? Now once try this ma third one. Try that third question ma. 1.5. Some people are saying ma 1.5. Shall we see now whether it is right or wrong? Okay now. Now we are looking at third one 0.25, 0.5, 0.75. Okay now. So after point maximum how many numbers ma? Two numbers, one number, two numbers. Maximum two numbers ma. So that's why first of all make all as a two numbers ma. Now I am reducing the steps ma. I am reducing the steps. First of all, whenever became all two ma, we can cancel the point. Now tell me directly ma after removing the point ma. After removing the point, first number will becomes ma. Sorry. First number will becomes 25, second number will becomes 50, Next number becomes ma 75. Now what we can eliminate ma? What we can eliminate ma? Clearly we can eliminate the 25. For the balanced numbers ma, take the LCM ma. For the balanced numbers, 25 twos, 25 threes. So what is the LCM ma? LCM ma? 25 twos are 53 is 150. Actually 150, but our numbers are decimal numbers. Ma. We should put back the point after two digits. Ma. 1, 2. So 1.50 means what is the LCM? Ma? 1.5. Right, ma? That is clearly right, ma. 1.5. Right, ma. Very good, ma. 1.5, ma. Right, ma. Very good. Right, ma. Now, first I said for normal numbers. Next I said for my decimal numbers. Now we are moving to power version, ma. Power version. Okay, na? Now, find the LCM of, find the LCM of. We are looking at power model, power. So in generally, here 2 is called as a base, 3 is called as the power. 2 is called as base, 3 is called as the power. 2 is called as the base, 3 is called as power. In whenever this kind is there, your answer two steps, two steps. First step is write down all the different bases. First step, write down all different bases. Different bases. Observe, it is one number, comma, it is one number, comma, it is one more number. Okay, na? Whatever the bases are there, write down all that. Okay, na? What are the bases? Observe carefully, ma. 2, one base. Inka ma. Next, 3. Next, 5. Next, 2 finish, 3 finish, 5 finish. One more is 7, 7. That's it. Okay, na? First step, write down all the different bases. Okay, na? After writing of that, for the different bases, we should write highest power. Highest power. Actually, in LCM, L means least, least. But here, we should write opposite. We should write highest power. Different bases with highest power. Highest power. For two, what is the highest power? Observe among all that, here for 2, 3 is the power. Here 4 is the power. Here 3. 3, 4, 3. Among the what is the highest power? 4. So for 2, highest power is 4. That is finished. Okay, na? Next, observe for 3. Observe for 3, here 4. Here not there. Here also not there. For 3, what is the highest power? 4. 4. 4. That is finished. Next, observe for the 5. Observe for the 5. Okay, na? For 5, here 2. Here 11. Here 4. 2, 11, 4. What is the highest power? 11. 11. For 7, here base 7 is not there, only here, only there. That is 2. 2. That is the answer. Okay, so whenever the question is in power model, first step, write down different bases. After writing of that, for that we should write highest power. Highest power. Different bases with highest power. Is it clear, Now try this, Try this, right, shall we see now? Now observe ma, 2 cube into 3 square into 5 power 4, comma 2 power 4 into 5 square into 7 power 11, comma 2 square into 5 cube into 11 power 4. Right ma? What I said ma, first of all write down different bases. What are the bases ma? Observe ma, 2, 2, next ma 3, next ma 5, next ma 7, as well as ma one more is ma 11. Right ma, 2 3 5 7 11, 2 3 5 7 11. Clear? With which powers I said ma? Highest power, highest power. For 2, what is the highest power ma? Here 3, here 4, here 2, 3 4 2. What is the highest power ma? 4. Chalo write down 4. Okay na? For 3, what is the highest power ma? Here 2, here not there, here not there. So highest power is 2. 2. For 5, what is the highest power ma? For 5 ma? Here 4, here 2, here 3. 4, 2, 3. Among that, what is the highest power ma? 4. 4. For 7, what is the highest power ma? Here only there ma, that is ma 11. For 11 ma, only here ma, what is that ma? 4. Right ma? Is it clear ma? Different 2 power 4, 3 square, 5 power 4, 7 power 11, 11 power 4. Right ma? Right ma? Some people are saying ma, correct answer ma? Right. 2 power 4, 3 square, 5 power 4, 7 power 11, 11 power 4. Right ma? Now, okay na? So different bases with highest powers. Different bases with highest powers. Right ma? Now, first I said for normal numbers, decimal numbers as well as for power numbers. And one more is there ma, that is ma fractions. But after discussing of HCF basic thing ma, then we should move to that ma. Okay na? Now we are talking about ma HCF ma. Now we'll look about ma HCF ma, HCF. HCF ma. What is the full form of HCF ma? Highest common factor. Highest common factor, or we can call as ma GCD also. We can call as ma GCD. GCD nothing but ma greatest common divisor. Right ma? HCF ma highest common factor, or we can call as ma GCD, greatest common divisor. In some books ma they will give GCF also, greatest common factor. In that way also we can say ma. Okay na? Now shall we see no ma? For example, 4, 6, 8. 4, 6, 8. These very small numbers ma. 4, 6, 8 ma. For this, if you wanted to find the HCF ma, HCF. Shall we see ma generally how can you find the HCF ma? As per full form, highest common factor. As per full form, first of all we should write ma factors. 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 Okay na? Factors. Factors means ma in which table you will get that. In which table you will get that ma. Okay na? Now factors of 4. What are factors of 4 ma? Factors means in which table you will get ma. 4 you will get in which tables ma? 1 table, 2 table as well as ma 4 table. Okay na? Those are the factors ma. And one more thing ma, don't get the confusion about multiple and factor. Earlier is ma least common multiple, multiple. Now we are looking ma highest common factor. In earlier case ma multiple, now the case ma factor. Multiple is different, factor is different. Multiple means simply table, table ma. Okay na? Factors means ma in which table you will get that ma, in which table ma. Don't get the confusion. Okay na? Now factors of 4 ma 1 2 4. Now factors of 6. What are factors of 6 ma? In which table we'll get 6 ma? 1, 2, 3, 6. 1, 2, 3, 6. Okay. Next ma, factors of 8. 8. What are factors of 8 ma? 1, 2, 4, 8. As per full form, first of all, we wrote the factors. Factors finished? Huh? From that factors, ma, we should select ma common, common, common. What is the common? Observe ma common ma. What is the common ma? 1 everywhere, as well as ma 2 everywhere. 4 here, there, here, but here not there. So common ma 1, 1 as well as 2 ma. 1 as well as 2 common. From that common ma, what is the highest one ma? 2. Highest one is 2. So HCF is how much ma? 2. Okay, now what I said ma? Basic method is first we should write the factors. From that factors ma, select the common. From that common ma, select the highest one. That is ma HCF ma, highest common factor. Okay ma. It is normal method ma. Just your idea purpose I shown, but we will not use ma. But we have to know that ma. Sure, you know what is the shortcut. Okay now. I'm taking the same numbers. Now we saw normal method ma. Now we are moving to shortcut. Shortcut. What is a shortcut means? Once observe careful ma. These all the numbers ma. These all the numbers. Are you getting any one table or not? We should observe ma. All the numbers we have to get ma. All the numbers ma. Okay na? All the numbers will get in which table ma? Observe careful ma. In two table. In two table we'll get all ma. Okay na? If you are getting all that ma, then we can take ma. Otherwise we should not take. Okay na? Two table ma. Now two twos, two threes, two fours. Now once again observe ma, these all the numbers except of one table ma, except of one table. In any one table you will get ma. We can't get any one table, so we can stop here. We can stop. If you are getting, then we can proceed. Otherwise not ma. Then we should stop. Now this side number is your HCF ma. We should not consider this one. We should not consider this one. So your HCF is 2. HCF is 2. What I said ma shortcut ma, observe carefully. All the numbers we are getting any one table or not. If you are getting any one table, you should consider that table. We'll see one more. One more. For example, 10, 20, 30. Observe ma, these all the numbers are getting any one table ma. That is clearly there ma 10 table. Okay na? If you're getting 10 table, take the 10 table ma. Ten, 20, 30. Now 10 table clearly all way to 10 ones, 10 twos, 10 threes. Still in any one table can you get all these ma? Except of one we can't get. So stop. So what is else? HCF ma 10. Your HCF is 10. HCF is ma 10. Is it clear ma? Okay. Now we'll see one more. 15, 20, some 40 I give. 15, 20, 40 ma. Observe carefully. All that numbers are getting any one table ma, any one table ma. If you observe carefully, all the numbers will get in which table ma? 5 table, clearly looking 5 table ma. So 5 threes, 4s, 8. Still any one table ma? 3, 4, 8. Can you get in any one table? No. So we can stop. So what is HCF ma? 5. This side number ma. This side number ma. HCF is ma 5. 5. Okay na? We'll see one more ma. 30, 60, 90. 30, 60, 90 ma. Observe carefully ma. These all the numbers you will get in which table ma? So 10 table. 10 table clear we are getting na? Now 10 to take the 10 table ma. 10, 3s, 6, 9s. 3, 6, 9s. Once again observe ma. These all the numbers can you get any one table ma? If you observe carefully ma. In which table ma? 3 table. We'll get all that ma. Now take the 3 table. If you are getting one, then we can continue. Otherwise we can stop ma. Now 3 ones, 3 twos, 3 threes. Again, observe carefully. Ma, any one table we are getting, ma? No. So we can stop this side, ma. This side. HCF is 10 into 3, ma. 10 into 3, how much, ma? 30. HCF, ma. 10 into 3, 30. It is my shortcut. Okay, ma. What I said, ma? If you are getting all the numbers in any one table, we can consider that, ma. We can consider that. Okay, we'll see some examples, ma. Find the HCF of. Find the HCF of 15, 25, 30, ma. 15, 25, 30. Observe, ma. 15, 25, 30, ma. These all the numbers, ma. Can you get any one table, ma? By looking, we can say simply, ma. These all the numbers in which table, ma? 5 table clearly. 5, 15, 25, 30. In clearly which table, ma? 5 table. 5 threes, 5 fives, 5 6. Observe again, are you getting all these numbers in any one table, ma? We can't. So stop. So your HCF is how much, ma? 5. HCF is clearly 5. 5. Okay, ma. If you're getting in all table, ma, all numbers in any one table, we can consider that one. Okay, no more continuation, ma. We can stop. So what is HCF, ma? 5. Now once try this, ma. Second as well as third. Once try that, ma. Second as well as third. Second, third, ma. 7, 7, 14. For the first question, second question 7, and third question 14. Some people are saying, ma. Shall we see, no, ma? Okay, now we are looking, ma. Second question, ma. 42, 63, 140. By observing all, you will get in which table, ma? 7, 7, 6, 7, 9, 7, 20. We can't get any one table, ma, so we can stop here only, ma. So what is HCF, ma? 7. Right, ma. 7 is right answer, ma. 7 is right. So answer is, ma, 7. 7. Okay. Now we are moving to next example, ma. 42, 70, 98, 126. By looking all this, ma, you will get in which table, ma? 7 table. 7, 6, 10, 7 1 7, 28, ma, 7 4s, 7 1 7, 56, ma, 7 8s. Observe again, ma, all these you will get in which table, ma? All these you will get in which table, ma? 6, 10, 14, 18, ma, you will get in two table, na? So take the two table. 2 threes, 2 fives, 2 sevens, 2 nines. Again, can you get any one table, ma? No. 3, 5, 7, 9, we can't get it, ma. So we can stop here only, ma. So this side, ma, this side, not 2, ma. Your answer is 7 into 2. Your answer is not 2, ma, not 7. Your answer is, ma, 7 into 2. How much, ma? 14. 7 into 2, ma, answer is 14, ma. 7 into 2, answer is 14. 14, ma. Okay, da? 7 into 2, answer is, ma, 14. Clear, ma? Okay, na? Right, ma. Now, we are moving to fourth question. Okay, na? 204 1190 1445, ma. 204 1190 1445. 204 1190 1445. Whenever bigger numbers are there, ma, we can't get the idea very soon, ma. Whenever you are not getting the idea very soon, then go through options, ma. Go through options, ma. Go through options. Okay, na? Whenever we are not getting the idea very soon, ma, then go through options. So among the numbers, ma, don't see the options one by one, ma. First of all, in your options, see the highest number because our intention only highest number, HCF, ma. Our intention highest number. So what is the highest number, ma? Among the options, highest number, first of all, 204. Shall we check now? In 204 table, 204 clearly we'll get. But 204 is even number, ma. In even number table, we can't get this 1445. So that is definitely not the suitable answer. So by looking, we can eliminate. It is eliminated. Eliminated. Okay, na? Now what is the next highest number, ma? 85. In 85. Generally, 85 number in 85 table, we'll get the numbers, ma. 85 ones are 85. 85 twos, how much, ma? 170. That means our last digit should be maybe 5 or maybe 0. Maybe 5 or maybe 0. But here, what is the last digit, ma? 204. So we can't get 85 clearly, ma. So we can eliminate the 85 also. 85 is eliminated. Now, what is the next highest number, ma? 34. Next highest number is 34. Shall we see now whether it is suitable or not, ma? 34. Okay. In 34 table, ma, once observe. In 34 table, in 34 table, generally, ma, generally in 34 table, ma, it is even number. In 34 table, you will get which kind, ma? 34, 68, such kind. In even number table, you will get the even numbers only. We can't get 1445. So that's why we can eliminate the 34 also. 34 also, ma. So definitely your answer should be, what is the answer, ma? 17. Your answer should be 17, ma. 17. By looking, we can eliminate, ma, 34, 85, 204. So finally, what is your answer, ma? 17 is the answer. 17. Okay, na? Because 34 is even number, ma. In even number table, we can't get last digit ending with 5. Okay, na? That's why directly 17 is your answer. So in that way. And one more method also there, ma. What is the one more method? Shall we see, no, ma? That is also we learned in school maths, ma. Sorry, ma. And one more, by looking, go through options, or as per our school maths method, ma, as per our school maths, among the three numbers, but take any two numbers, ma. Let us take first and second, ma. In school maths, ma, we can follow in this way, ma. 204 nearly how many times, ma? Once check that, ma. 204 table 1190 is nearly how many times, ma? 6 times means 1200, it will cross. So 5 times. 5 times. How much, ma? 5 times, ma? 1020. 1020. 071. With 170 divide the 204. 170 ones 170. 4 3. With 34 divide the 170. In 34 table clearly 5 times 170. 0. When remainder 0, then stop. Then stop. With this 34, what is the one more number balance, ma? 14, 14. With 34, ma, we should divide, ma, one more number, ma, 14, 45. With 34, divide the 1445 with 34. With 34 to divide the 14, 45. Now in 34 ma, see entire ma, see entire, not see it on the 3 digits or such kind ma. See entire number, how many times ma? See entire number. 34 table ma, nearly entire times ma. 34 10, so much ma? 340. 34 20 is ma, 34 20 is ma, 340, 340 ma, 680. We are not getting near ma, near. 34 30 is. 34 30 is how many times ma? 34 30 means how much ma? 3 4 the 12, 1 carry 9, 11, 1 0 2 0. 34 fours, 34 fours also you'll get ma, 4 4 the 16, 136 ma. More. 34 4 times also more. So we will take ma more than 40 ma. If you take the 34 40s ma, 34 fours, 16 1 carry 12 136. If it is 40 ma, sorry, if it is 40 times ma, 1360. But our number is more than 1360 ma, more than 1360 ma, nearly 85 is there. So roughly we can take ma 2 times ma. Now 42 into 34. 4 2 is 8, 4 4 is 16, 3 2 is 6, 3 4 is 12. 8, 12, 1 carry 4, 1 4 2 8 ma. Nearly 1 4 2 8 ma. 4 2 is 8, 16, 6 12 ma. 8 12, 1 carry 1 4 2 8. So nearly 42 times 1 4 2 8. Okay. 15 minus 8 ma 7, 3 minus 2 ma 1. With 17 divide the 34. 17 to 34, remainder 0. Then stop. This side number ma. So your answer is ma 17. Answer is ma 17 ma 17. Okay, na? Answer is ma 17 ma. It is our school maths method ma. Compared to this, through option we can save the time ma. We can save the time ma. But if you are not convenient with options ma, then go through normal school maths method ma. Okay, na? What I said ma, first method, shortcut method is shortcut is ma. If you are reading all that numbers in which table, we should take that ma. Okay, na? When a bigger numbers ma, go through option verification. If you are not suitable with option verification ma, it is a normal traditional school maths method. Based on our convenient ma, you can choose any one method. Okay. Now I shown for normal numbers ma, normal. Now we are moving for same like LCM ma, decimal numbers ma. Okay. Now we are talking about ma decimal numbers. In LCM I shown which way ma. In HCF also first step is same. First of all, make all the numbers equal. Make all the numbers after point, make all the numbers equal. Make after point one number, two numbers, three numbers, four numbers. Maximum how many numbers are there ma? 4. To make all the 4, wherever less there we should write the zeros. Okay. Now directly I'm doing ma, already I said earlier clearly, that's why I'm doing a direct step. Okay. First of all, to make the all 4, wherever less there we should write the zeros. Here we need to write how many zeros ma? 3 zeros. Because 4 we have to get the 4, so that's why we need to write ma 3 zeros ma. By writing 3 zeros ma, points will cancel. Now I'm writing ma directly. But the first number will become ma 1000. Second number will become ma 100. Next number will become ma 10. Next number will become ma 1. Now all the numbers are became normal. What I said in shortcut ma, HCF, we are looking HCF ma. What is it the shortcut ma? If you are getting all the numbers in any one table, that we should take. Observe carefully, all the numbers you will get in which table ma? Only one table. Other than one, we can't get any one table. Okay now, only one table. So that's why what is HCF ma? 1. HCF 1. We should put back the point after 4 digits, after 4 digits. So 0, 0, 0 point. So what is the answer? 0.0001. 0.0001. Okay na? Now once try this one. Try these three ma. Try these three. Okay na? First of all, what is it ma? After point, maximum how many numbers are there? Make in such a way. After that, remove the point. Then find the HCF. Then we should put back the point as it is ma. Okay na? Now once try that ma. Right ma. I will say okay. First ma, what I said ma, first what I said, make all the numbers maximum. Okay, maximum 4 digits. So make all as a 4 numbers ma. 4 here there. Here also we need to make 4. We need to make the 4. Only one number is there. We should write the 3 zeros. So 1000. Okay na? Here ma 2 digits are there. To make the 4 we should write ma 2 zeros. Here 3 numbers we should to make the 4 we should write ma 1 0. By doing in such a way ma all the points will cancel ma. So 1110 1. 1110 1. Okay na ma 1110 1. After by doing in such a way ma all the numbers are became normal ma. Observe carefully ma. What I said for normal numbers ma. If you are getting all the numbers in which table, that we should know. These all the numbers you will get in only one table. Other than one we can't get any one ma, because last number is 1. So directly what is the HCF ma? 1 ma. Okay na. We'll see one more ma. I will say one more. Second question also I will say. Then you will get the clear idea ma. Okay na. Now second ma. What is second one ma? I will show clearly. 1 second ma. 0.2, 0.02, 0.002, 2.0. First of all, what I said, after point, make the number of terms equal. That is also maximum. Maximum here 1 there, here 2 there, here 3 there, here 1. Maximum how many there ma? 3. So first of all, make all as a 3, 3. Wherever less, there we should write ma zeros. Okay. Now, to make the 3 ma, we should write 2 zeros. To make the 3 ma, we should write ma 1 0. It is clearly 3, no problem at all. To make the 3 ma, we should write ma 2 zeros. All became 3 3 na. Now we can cancel the point ma. Now what is the number? It is clearly 200. It is clearly 20. It is clearly 2. That is clearly 2000. Now all became normal ma. HCF. Observe all the numbers are getting in one table ma. Which table ma? 2 table. 2 hundreds, 2 tens, 2 ones, 2000. Again we can't get any one table all this ma, except of one ma. So we can stop here only. So what is HCF ma? 2. HCF is 2. But 2 is not the answer. We should put the point after 3 digits. After 3 digits ma. Because we remove the point after 3 digits ma. So 1 0 0 0. So your answer is ma 0.002. That is the answer. 0.002 is not the 2 ma. 0.002 is the answer. 0.002. Okay ma. 0.002. That is clear. Right ma? Clear? Any doubt ma? Now once try this ma. Once try this third one ma. Then you will get the idea. Once try that method, you will get the idea. Point 0.25, 0.25, right pa. First of all, right pa, 0.25, 0.25, right pa. Here two numbers, one number, two. So we should make all as a two numbers ma. All we should make as a two numbers ma. So to make the two ma, first number 25 clearly. Next number will become ma 15. Next one will become ma 75. Became normal numbers. So all you will get in which table ma? 25. 1, 2, 3. Still we can't get anywhere. So what is HCF ma? 25. When normal numbers 25, but our numbers are decimal numbers ma. So we should put back the point after 2 digits ma. So what is the answer ma? 0.25. Right ma? 0.25 is correct answer ma. 0.25. Now try this ma fourth. Try the fourth question, ma. 0.12. 0.12, 0.12. So people are saying ma 0.12. So first of all, ma, here one digit, two digit, one digit. So we should make all as two digits, ma. To make the two digits, ma, after making two digits, ma, point directly will cancel. So first number will becomes as 240. Next number will becomes as ma 36. Next number is ma 7. All numbers will get in which table, ma? 12 table. So take the 12 table, ma. 12 2 0, 12 3, 12 6. Still anywhere, ma? No more, na? So we can stop. 12. When normal numbers 12, but our numbers are point numbers, ma. We should put the point after two digits, ma, as it is, ma. So 1 2. What is the answer, ma? 0.12. Right, ma? 0.12 is right answer, ma. 0.12. Right, ma? First I said for normal numbers. Next I said for my decimal numbers. Now we are moving to power. Power. Find the HCF of. It is entire one number, ma, comma, it is one more number. Two digits, ma. It is one number, comma, it is one more number. Now here, ma, this model I said in LCM also. In LCM, what I said, ma, different bases with highest power. In LCM, ma, I said, ma, different bases with highest power. Now we are looking, ma, HCF, ma. This kind of model is there, ma, in HCF, ma. First of all, we should write, ma, common bases. Common bases. In both way, it is one, comma, it is one. In both cases, observe what the common base. Two here, there, here also there. So we can take two. Next, three here, there, here also there. So we can take three. Five here, there, here also there. So we can take the five. Seven here, there, but here not there. We can't take. Okay, now what I said, my common basis. After taking of common basis, ma, with least power, least power, common base with least power, ma. In LCM, ma, different base with highest power. Here, ma, common base with least power. Okay, now least. Observe for the two. For two, what is the least power, ma? Here three, here four. Least power is three. Okay, now next, ma, for three, what is the least power? Here four, here two. Least power is two. For five, here two, here 11. Least power is two. That is the answer. Right, ma? What I said, ma? Common base with least power. Common base with least power. Right, ma? Now try this second question, ma. Try that, ma. Second question. Common base with least power. It is one, comma, it is one, comma, that is one. Right, ma? 2 cube into 3 square, 2 cube into 3 square. Right, ma? What is the common basis, ma? If you observe carefully, ma? 2 here, there, and here also, there. 2 is the common base. Next, ma? 3 here, there, here also, there. 3 is the common base. Still, ma? 5 here, there, but here not there. We can't consider. 7 here, there, we can not there. We can't consider. Okay, na? Only the 2 and 3. For that, we should write ma least power. Least power. For 2, what is the least power, ma? Here 4, 3, 5. What is the least power, ma? 3. For 3, what is the least power, ma? Here 3, 2, 4. 2 is the least power. Right, ma? 2 cube into 3 square, ma? Right, ma? 2 cube into 3 square, ma? Right, ma? Is it clear, ma? Now, I said for power numbers also. Right, ma? Now we are moving ma fractions. When fractions are there, ma, just remember the formula, ma. LCM of fractions formula, LCM of numerators by HCF of denominators. LCM of numerators by HCF of denominators. And whereas HCF of fractions formula, ma, HCF of numerators by LCM of denominators. Ma. When fractions are given, we have to use the formula. LCM of fractions formula, LCM of numerators by HCF of denominators. Here, ma, don't get the confusion, ma. If you are finding LCM, then LCM only in upside position. Okay, na? If you are finding HCF, then HCF only in upside position, ma. Don't get the confusion, ma. What is the LCM of fractions formula, ma? LCM of numerators by HCF of denominators. What is the HCF of fractions formula? HCF of numerators by LCM of denominators. Right, ma? Is it clear, ma? Now, shall we see now, ma? Find the LCM and HCF of for the first question, ma. Now I will show my first question. First question, ma. 1 by 2, 4 by 11, 8 by 3. Now I want to find my LCM. LCM. Just now I shown ma. What is the LCM of fractions, ma? LCM of numerators by HCF of denominators. So LCM of numerators. That means LCM of which numbers, ma? 1, 4, 8 by HCF of which numbers, ma? HCF of denominators, ma? 2, 11, 3. Right? In LCM, what is the shortcut I said, ma? In LCM, shortcut is elimination. Elimination. Can you eliminate any numbers, ma? One table we will get all this. We can eliminate 1. In 4 table we will get the 8. We can eliminate the 4. Only 8 is balanced. So what is the LCM, ma? 8. Chalo, LCM 8. By in HCF, what I said the shortcut, ma? If you are getting all the numbers in any one table, that will become the HCF. 2, 11, 3, ma. These all the numbers. Can you get any one table, ma? Only one table. Other than one table, we can't get anywhere. So what is HCF, ma? 1. 8 by 1 means what is the answer, ma? 8. 8 by 1 means what is the answer, ma? 8, ma. Right, ma. Right. Answer is ma 8, ma. Next, ma, HCF. HCF. For HCF, ma. For HCF, ma, what is the formula I said, ma? HCF of fractions, ma. HCF of numerators by LCM of denominators. Okay, ma. So HCF of numerators, that means HCF of 1, 4, 8 by LCM of which numbers, ma? 2, 11, 3. Okay, na? 1, 4, 8. In HCF, what is the shortcut I said, ma? All numbers are getting any one table. Only one table because 1 is there, ma. Only one table. Other than 1, we can't get any one. So HCF is how much, ma? Clearly 1 by 2, 11, 3. Can we eliminate any numbers? We can't. Okay, just now this we can't get any one table. So what is LCM, ma? 2 11s 22, 22 3s, ma? 66. So what is the answer, ma? 1 by 66. Not 4 by 66, ma. 1 by 66, ma. 1 by 66, ma. It's not 4 because HCF, ma, 148 HCF is 1, not 4, ma. Okay, na? 1 by 66 is the answer. 1 by 66, ma. Right, ma? Now try this, ma. Find LCM as well as my HCF. Try both. Do the both. LCM 12, HCF 1 by 63, LCM 12, HCF 1 by 63. Right, ma. Shall we see now whether it is right or wrong, ma? Shall we see now? So, LCM, ma, for the second question, we are looking, ma, LCM. LCM of numerators 2, 4, 3. 2, 4, 3 LCM, ma, we can eliminate 2. What are the 4 and 3 LCM, ma? 12. By HCF forma 3, 9, 7. You can't get any one table, ma. So HCF is 1. 12 by 1, right, ma? Answer is 12. Answer is, ma, 12. That is clear. Now HCF, ma. HCF, ma. HCF for the numerators, ma. 2, 4, 3. We can't get any one table of these all only except of 1. HCF is 1. By LCM of 3, 9, 7. We can eliminate ma 3, 9, 7 LCM ma 63. Right ma 1 by 63 correct answer. 1 by 63. Right ma clear. Now I shown for normal numbers, decimal numbers, power numbers as well as ma fractions also. Right ma these 4 cases we saw. Right ma. Next example ma next. Now we are looking for ratio based. Ratio based. Earlier normal case, but now we are looking about ratio. Okay, na? Now observe my first question. Two numbers are in the ratio 2 is to 3 and their LCM is 60. Find that two numbers. Find that two numbers. What I said, ma? Two numbers are in which ratio, ma? 2 is to 3 and their LCM is how much you are saying, ma? 60. What are the two numbers? What are the two numbers? Now two numbers are in the ratio ma 2 is to 3. Let assume ma, actually we don't know first, we don't know second ma. Let assume ma, first number assume as 2x, second number assume as ma 3x. We don't know ma, let assume ma 2x as well as 3x ma. He was saying ma for this LCM, take the LCM ma. In both what are the common ma x, 2's, 3's. So what is the LCM ma? 3 2's are 6x. 6x ma. As per our assumption, what is the LCM 6x ma is equals to, as per the question, what is the LCM 60. 6x equals to 60 ma. If 6x equals 60 ma, 6 ones, 6 tens. What is the x value ma? 10. If x is 10, if x is 10, what are the numbers ma? 2 tens, 20, 3 tens ma? 30. What are the numbers ma? 20 and 30, 20 and 30, 20 and 30. Is it clear ma? Okay ma? Numbers we don't know ma. Let us assume ma 2x as well as ma 3x. For that LCM, as per our assumption, LCM ma 6x. As per problem ma 60. 6x equals 60 ma, so x equals to 10. That means 20 and 30 are the numbers. 20 and 30 are the numbers. Okay na? Right ma. Now same ma. Three numbers are in the ratio 2:3:5 ma. 2:3:5. Three numbers ma. He was given ma three numbers ma. Now three numbers ma. So first number will assume as ma 2x, 3x, 5x. In all comma x, 2, 3, 5. What is the LCM ma? 5 3 is 15, 15 2 is 30. 30x ma. 30x as per our assumption, but as per problem, what is the LCM ma? 120. 30x equals to 120. 34. If x is 4, if x is 4, what are the numbers ma? 2 4s are 8, 3 4s 12, 5 3 4s 20. So 8, 12 and 20. 8, 12 and 20. Okay ma? So whenever the ratio measurement, just let us assume that split the ratio and take it as beside of that x ma, then we can solve very easily, very easily. Okay na? So ratio based visa. Okay na? Now next ma. In earlier question ma, two numbers ratio given, three numbers ratio given clue is LCM. Now for us ma, now for us given clue is HCF ma. Two numbers on which ratio ma? 2:3 and HCF is 5. HCF is 5. Find that two numbers ma. Find that earlier clue is LCM. Now the clue is ma HCF ma. HCF. Okay na? Let us do the same. 2x, 3x. We don't know numbers ma. Let us assume 2x. Now we are talking about HCF ma. In HCF, what I said ma? If all the numbers are you getting any one table, both will get in which table ma? X table. X2s, X3s. Again we can't get. Then stop. HCF means this side number. So what is HCF ma? X. As per our assumption, HCF is X. But as per problem, what is HCF ma? 5. So X equals to 5. If X is 5, what are the numbers ma? 2 5s are 10. 3 5s 15. So numbers ma 10 and 15. Numbers are 10 and 15. Okay ma? Is it clear ma? So first of all, 2:3 ratio ma. We don't know numbers. Let us assume 2x, 3x. 2x, 3x ma. HCF ma x. As per our assumption ma HCF x. But as per problem 5 ma. X equals to 5. That means 5 2 is 10, 5 3 is 15. Okay. Now we'll move to the next example ma. This is okay na? Now three numbers are in the ratio 2:3:4. Three numbers are in the ratio ma 2:3:4. HCF is how much you are saying ma? 12. 12. Find the numbers, find their LCM. I give two questions. Find the numbers as well as find their LCM. Now ratio is 2:3:4 ma. So take it as ma 2x, 3x, 4x. Now our clue is HCF. HCF. All you will get in which table ma? X. 2s, 3s, 4. Still again, can you get anywhere ma? No more na? So what is HCF ma? X. As per our assumption, HCF is X. But as per problem, what is HCF ma? 12. X equals to 12. If X is 12, what is the first number? 2 12s. 24. 3 12s. 36. 4 12s. 48. These are numbers. Numbers ma. 24, 36, 48. Numbers. Okay na? But I give two questions ma. Find the number, that is clear. Find their LCM also I am given ma. Now shall you see ma? Finding the LCM ma. Now we are moving to second one ma. Second one. 24, 36, 48. In LCM, what I said ma? Elimination. Can we eliminate any number ma? Clearly 24 we can eliminate. Okay na? 36, 48 ma. In which table ma? We'll get in 12 table na? 12 3s, 12 4s. Still we can't get anywhere. So what is LCM ma? LCM 4 3s are 12 12s, 144. 144. Right, ma? Clear? Any doubt, ma? Okay, now. Now I said ma ratio model ma when LCM clue is given as well as ma when HCF clue is given ma. Take it as ma X ma, then for you convenient ma, you can't feel any difficulty ma, within 2 3 steps ma we can simplify ma. By practicing ma you can save the time also ma. Okay na. So now we are talking ma purely up to now I said ma LCM as well as HCF both I said. Now we are looking ma only purely LCM based examples ma, purely LCM based examples. Okay ma. Now what is the first question? Find the least number. Find the least number which is exactly. Find the least number which is exactly divisible by 2, 3, 4, 5, 6, 8, 10, 12. Whenever these kind of numbers, two methods. One is procedure, one is options. I am not given options. When our options are not there, general. You have to know both methods. What is procedure? What is when through options? Okay, now we have to know both. Sometimes options are bigger numbers, but then becomes a little bit difficult. At that time, procedure is better. That's why you have to know as a two methods. Procedure. First of all, read the question. What is the question, ma? Find the least number. We have to know least. That should be exactly divisible by all these numbers. All these numbers means we have to get in two table, we have to get in three table, we have to get in four table, we have to get in five table. We have to get in all tables. We have to get in all tables means that should be common multiple. Common multiple. That is also least number. So first of all, just LCM. Whenever the question is exactly, just find the LCM. LCM. That is the answer. LCM. LCM. Okay, now that means LCM of which numbers? 2, 3, 4, 5, 6, 8, 10, 12. Okay, now? Right, ma? What is the question, ma? Least number, and that should be exactly divisible. Exactly divisible means we have to get in all tables. There is also least, ma. So that's why LCM. Now, in LCM, what I said, ma? Elimination, ma. Can we eliminate any number, ma? 2, we can eliminate. 3 table, we can eliminate. 4, we can eliminate. 5, we can eliminate. 6 also, we can eliminate. 8, can we eliminate, ma? We can't. 10, we can't. 12, we can't. What are the balance numbers, ma? 8 and 12. For those only take the LCM. LCM. Now, which table, ma? 2, 4, 5, 6. Again, ma? 2, 2, 5, we can't get 2 threes. That's it. What is the LCM? 2 2s are 4, 4 2s are 8, 8 5 is 40, 43 is 120. So our answer is 120. Our answer is 120. Least number, and that should be exactly divisible. Example. Just find the LCM. That's it, the answer. Find the LCM. That is the answer. Okay, na? Right. Next one. The least number which when divided by 4, 6, 8, 12 and 16 leaves a remainder of 2 in each case is leaves a remainder of 2 in each case is. Observe carefully, ma. Earlier question is exactly divisible, ma. Earlier question, ma. Earlier question is exact, but now the question is not exact, ma. In everywhere, what is the remainder we require, ma? 2. 2. Okay, that is the reference, ma. So that means by dividing the 4, we have to get the remainder 2. By dividing the 6, we have to get the remainder 2. By dividing the 8, we have to get the remainder 2. By 12, by 16. By dividing any one of these numbers, ma, we have to get the remainder 2. Remainder. As well as that should be least, ma. So procedure is, ma, LCM is exact divisible number. LCM is exact, but we don't want exact divisible. We require every case what is the remainder, but 2. That's why LCM plus remainder. It is procedure. Procedure is LCM plus remainder. Okay, now LCM, can we eliminate any numbers? 4 we can eliminate, 6 eliminate, 8 also we can eliminate, 12, 16. What is the 12, 16 LCM? 4 3s, 4 4 4. So 12 fours are 48. LCM 48, but our answer is LCM plus remainder. 48 plus 2, how much ma? 50. 48 plus 2 ma? 50. That is procedure ma. Procedure is LCM plus remainder. Okay. Na? Otherwise, we can move through option verification ma. Option verification also we can move on. How to options ma? Shall we see no ma? By dividing the 4, we have to get the remainder 2. By dividing 6, we have to get the remainder 2. Which option will satisfy this condition? That is your suitable option. Options, but don't see serial wise. Options, in options, first of all, we should check what is the list. Among the options, 46 is least number. Now, dividing with 4, 4 ones are 4, 4 ones are 4. Remainder 2, okay. With 6, 6 sevens are 42. What is the remainder? 4, but we need to get a remainder but 2, so it is not suitable, it is eliminated. Now with 4 it is clearly divisible, but we don't want clear bar, we require remainder 2, not suitable. Go for next. 4 12 48, remainder 2, okay. 6 6 8 are 48, remainder 2, okay. 8 8 6 are 48, remainder 2, okay. 12 12 4 48, remainder 2, okay. 16 16 3 is 48, remainder 2, okay. It was satisfying all conditions, so definitely what is the answer? Option C. Option C ma. Okay na? Procedure is LCM plus remainder, or we can move through options ma. Move through option, which option will satisfy the condition. Okay na ma? Earlier question ma, exactly divisible, at that time just LCM. Now we require ma remainder, so LCM plus remainder, LCM plus remainder. Okay na? Now next ma, find the least number which is divisible by 40, 50, 60, leaves a remainders of 10, 20, 30 respectively. 10, 20, 30. Earlier question ma, everywhere same remainder 2. Now everywhere not same ma, everywhere we require different remainders ma. By dividing with 40 ma, by dividing with 40 we require the remainder how much ma? 10. By dividing with 50, we require the amount how much more? 20. By dividing with 60, we require the amount how much more? 30. In all cases, we require different remainders. Different. Whenever different remainders, then how to approach? Okay. Now, first of all, observe difference. 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 40 minus 10, how much more? 30. 50 minus 20, how much more? 30. 60 minus 30, how much more? 30. All the difference are same. Always all the difference, always you will get the equal only these are not different, you will be there that cases does not exist, always you will get the same only. Okay now whenever different remainders, how to approach means LCM of given numbers, LCM of 40, 50, 60 minus difference. From LCM, we should subtract the difference. Subtract the difference. 40, 50, 60 LCM. 40, 50, 60 LCM. All 10 table. 10 fours, 10 fives, 10 6 next 2 table. 2 twos, 5 econ, 2 3. That's it. What is the LCM? 10 twos 20, 40, 200, 600. LCM is 600. So our answer is 600 minus difference. Difference is how much 30. 600 minus 30. So what is the answer 570. Answer 570. 600 minus 30 570. Is it clear 600 minus 30 answer is 570. Now I said 3 models. Exactly, leaving same remainder, leaving different reminders. Exactly means just LCM. Leaving same remainder means LCM plus remainder. Leaving different reminders means LCM minus difference. Okay. Now, when question is exactly just LCM. just LCM. Okay na? When leaving same remainder means ma LCM plus remainder. LCM plus remainders. Next ma leaving different remainders means ma LCM minus difference. Okay na? When exact ma procedure ma option for every question you can move through option also ma. Procedure means exact means LCM, leaves same remainder means LCM plus remainder, leaves different remainders means LCM minus difference. Okay na? Now what is the question? Observe ma. Find the least number. Find the least number which is when divided by 16, 18, 20 leaves a remainder of 4 in each case ma. By dividing with 16 we require remainder 4. By dividing with 18 we require remainder 4. By dividing with 20 we require remainder 4. But it is completely divisible by 7. Completely divisible by 7 means ma by dividing with 7 ma there is no remainder. Completely divisible means there is no remainder. That means remainder should be 0 ma. Here ma two conditions are there. Two conditions ma. By dividing with 16, 18, 20. In this case, we remainder required ma 4. By dividing with 7 ma, there is no remainder. There is no remainder means remainder should be 0. Completely divisible by 7 means ma, we require remainder 0. Two conditions. It is one condition, that is one more condition ma. Okay na? Procedure means ma, if only first condition is there, how to approach ma LCM plus remainder. As per the first condition, just LCM plus remainder. Now shall we see what is LCM ma? We can't eliminate anyone ma. So take the normal. Can I take two table ma? Two 8s, two 9s, two 10s, two 4s, 9 we can't, two 5s. Still anywhere ma? No more na? 5 9s 45, 45 4s 180, 182s 360, 362s ma 720. LCM 720. As per the first condition ma, we require remainder 4. Then how to approach ma LCM plus remainder? So 720 plus 4, 724. This number ma will satisfy first condition. That is clear. First condition will satisfy definitely. But it has to satisfy second condition also. What is second condition ma? That should be exactly divisible by 7. Shall we check now whether it is divisible by 7 or not ma? 7 1 is 7. 24. Can I get 7 table ma? No, that is not suitable. If it is suitable with 7, it is divisible by 7, there is no problem. That is clearly answered. But 724 is not divisible by 7 ma. Then how to approach ma? By taking the multiples of 720. Multiples of 720. That means 720 into 1 plus 4. 724 not satisfying. Go for next multiple. 720 into 2 plus 4. Why? Because plus 4 ma for the sake of first condition purpose. 720 into 2 ma 1440 plus 4. 1444. Check it ma. Is it divisible by 7? 7 to the 14. We can't get 7 table. Go for next. 720 into 3 plus 4. 720 into 3 ma 2164. 7 is 21. We can't get this one. Go for next. 720 into 4 plus 4. 720 into 4 how much ma? 2880 plus 4. 2884. 2884. 7 4 is 28. 7 1 is 7. 7 2. It is clearly. So what is the answer ma? 2884 ma. 2884 is the answer. 2884. It is procedure. Otherwise, you can move through option also, ma'am. We can move through option also. Now, while doing the options, ma, First of all, check the second condition, not first. Check the second condition. Which option first of all divisible is 7? Check down. 7 6 are 42, 4 45. It is clearly not divisible by 7, so that is eliminated. Okay. Now we require least. That is finished. Among the balance bar, it is the least one. 7 4 the 28, 7 1 7 4. It is clearly divisible by 7. Shall we check now remaining options also, ma? 7 4 are 28, 4 43, 7 6 are 42, 1 15. We can't get in 7 table, so eliminated. 7 4 are 28, 4 43. 43 means 7 6 are 42, 1 balance 14, 7 2 is 14. It is also divisible by 7, it is also divisible by 7. Both are. That means your answer may be B or maybe C. So among the options, first of all, we should go for C because least number. Among these, least is C. First one. It was satisfying second condition. If it is satisfies first condition, that is definitely. Now 16 table by dividing with 16, what is the remainder we look at? 4. Now check now. 16 ones are 16. How much balance ma? 12. 128. 128 means ma in 16 table how many times ma? 16 table 8 times ma 128. Remainder 4 clearly. Next 18. 18 ones are 8. 10 108. 86 are 108. Remainder 4, that is clear. Anyway, by looking we can say 20 table also remainder 4. So what is the answer? Option C. We can follow procedure or by looking go through option. While moving through options, first of all check the second condition. After that only go for first condition. Okay na? Now we are looking at next example. The smallest number which when increased by 5. 1 second ma. Now next ma. The smallest number. Now we are looking at another model. The smallest number which when increased by 5 is divisible by each 24, 32, 36 and 54. What is the question ma? The smallest number. The smallest number which when increased by 5. When increased by, not directly ma, which when increased by 5, that is exactly divisible by 24, 32, 36, 54. One is again through option verification or procedure means whenever increase the word is given, your answer should be LCM minus 5. If it says increase, we should deduct the minus 5. If it says decrease, we should add that one. We should add that based on the question, opposite version. Okay, now that is not exactly when increased by 5 means we should subtract the 5. We should subtract the 5. So LCM 24, 32, 36, 54. 24, 32, 36, 54. Can we eliminate any number 24 we can't, 32 we can't eliminate any number no. So go through normal shall we take no which table can we take 2 table? 2 12s, 2 16s, 2 18s, 2 27s. We can't eliminate. Shall I move to 3 table 3 4s, 16 we can't, 3 6, 3 9s. Here what we can eliminate 4 we can eliminate, and that's it. Now which table 3 table, 16 we can't, 3 2s, 3 3s, 2 we can eliminate, 16 3 we can't. What is the LCM 2 3 ja 6, 6 3 ja 18, 18 3 ja 54, 54 into 16 54 16 16 4 ja 64, 6 balance, 16 5 ja 80, 864 minus 5. 864 minus 5. That means what is the answer 859. Answer ma 859. 859. Okay, na ma? When the question is increased, we should not increase ma. From the LCM, we should subtract because that is not directly divisible. When increased divisible, that's why we should deduct that. Ma. We should deduct that. Okay, na? Now, now try this one. Find the least number which when decreased by 4 is exactly divisible by 9, 12, 15. When decreased by 4, then how to approach ma? For the LCM, we should add the 4. Add the 4 ma. Try that ma. Try that. Right ma. People are giving 184 as the answer ma. Shall we see now? Find the least number which when decreased by 4 is divisible by 9, 12, 15, 18 ma. So what is it ma? When decreased by 4 ma, LCM plus 4. LCM plus 4 ma. So LCM plus 4. Now we can go through options also. We can go through options also ma. Okay na. Now in LCM while finding LCM we can eliminate clearly 9. because in 9 table we'll get the 18 ma. 12, 15, 18 LCM ma. 12, 15, 18. In which table ma? 3, 4s, 5s, 6. 2 table ma? 2s, 5 econ, 2 3s. So what the LCM ma? 3 to the 6, 6 to the 12, 12, 5, 60, 63 is a 180. 180 plus 4. So what is the answer ma? 184. 180 plus 4 ma? 184 is the answer. Is it clear ma? Right ma? Now, next ma. Or you can move one by one options through. What are the options? By through options ma? By dividing which number decrease by the 4 ma. Just if you go for 9 ma, 9 table, 9 to the 18. Here 4 we are getting extra. That is clearly. Okay, now decreased by 4 you are saying. Okay, now what the next ma? We are looking for next model. Next model. Earlier I said ma decreased, increased. Now we are looking for next model. Find the greatest 4-digit number which is exactly divisible by 8, 10, 12. Okay, now what I said ma? Find the greatest 4-digit number. We require greatest 4-digit number that should be exactly divisible by ma 8, 10, 12. That means we have to get in 8 table, we have to get in 10 table, we have to get in 12 table. We have to get in 8 table, we have to get in 10 table, we have to get in 12 table, as well as that should be greatest 4-digit number. So we have to get in all the tables ma. So first of all we should find ma LCM. LCM of 8, 10, 12. Okay na? LCM of 8, 10, 12. Now 2, 4s, 5s, 6. 2s, 5 econ, 2 3s. 2 to the 4, 4 to the 8, 8 5 40, 43 is 120. What is the LCM ma? 120 ma. Here ma, we have to get in 8 table, 10 table, 12 table. Nothing but indirectly we have to get in 120 table. We have to get in ma 120 table. We have to get in 120 table, as well as that should be greatest 4-digit number. Greatest 4-digit number. At that time, actually, in generally, what is the greatest 4-digit number ma? What is, sorry ma. Actually, what is the greatest 4-digit number ma? 9999. Okay na? Greatest 4-digit number ma? 9999. Right ma. We have to get in 120 table ma. Okay na? If it is 120 table, if you are getting it is clearly, that is only the answer ma. If not, what will happen shall we see now. Okay na? With 120 ma, divide the 9999. Now 120 ma 3 digits. Observe up to 3 digits ma. In 120 table, how many times ma? 8 times. 960. 9, 3. Drop the 9. In 120 table ma, how many times ma? 3 times. Nearly 3 times ma. 123s. 360. 9, 3. What is the remainder ma? 39. Whenever remainder is 39, when remainder is 39, that is not exactly divisible. Not divisible. Remainder means that is excess only there ma. That is excess. If you remove that, that is exactly divisible. So our answer is ma. Our answer is 9999 minus this remainder ma 39. So 0, 6, 9999. So what is the answer ma? 9960. Your answer is ma 9960 is your answer. Is it clear ma? Okay na? What I said ma, find the greatest 4-digit number which is exactly divisible by all this. Divisible by all these means we have to get in all tables. That means LCM. LCM ma 120. That means indirectly we have to get in 120 table ma. In 120 table that should be divisible, as well as that should be greatest 4-digit number. Actual greatest 4-digit number ma 9999. 120. It was not dividing clearly ma. Remainder getting means that is excess. If you remove that, exactly divisible. So our answer is ma 9960. Okay na? Now next ma. Earlier I said ma greatest. Now we are looking ma least. Find the least 5-digit number which is exactly divisible by 8, 10, 12. Earlier question greatest 4-digit. Now the question least 5-digit. Least 5. That is the difference your idea purpose I am given same numbers 8, 10, 12. Same given I am given. Okay. So already we learn what the LCM of 8, 10, 12. LCM in previous problem already we did. What is the LCM 120. LCM 8, 10, 12. LCM 120. Same logic we have to get in 120 table as well as that should be least 5-digit number. Actually, what is the least 5-digit number 1 0 0 0 0. We require 5 digits 1 2 3 4 5 digits. Okay now same logic 10,000 divide with 120. 120 3 digits up to 1000 we can observe 120 table nearly how many times 128. 128 so much 960. 0 10 minus 6 4 1 4 sorry 0 40 drop the 0 400 in 120 table 400 nearly how many times 123 123 so much 360 0 40 remainder 40. That means it is not divisible exactly. 40 remainder means 40 is excess there. Excess okay now 40 is excess. If you subtract that 40 divisible. But we should not subtract because by subtracting 40 from this what will happen that will become 4-digit number when you subtract the 40 that will become 4-digit number. But we not require such kind. We require the 5-digit So earlier case we can subtract but in earlier problem I said subtraction when greatest means but when in present our question is smallest we should not subtract we should add what we should add means our answer should be for 10,000 we should add what we need to add means difference of these two. Difference of 120 and 40 that the thing we should add. Difference of 120 and 40. 120 minus 40. 120 minus 40 how much 80. So 10,000 we should add 80. So your answer is 10,080. Answer is 10,080. Is it clear Whenever greatest subtract the remainder. When least for that number we should add what we need to add difference between divisor and remainder. Difference between divisor and remainder that we need to add okay don't get the confusion So LCM finding is same for both. When greatest subtract the remainder, that's it. But when least for whatever the least number for that we should add the difference between divisor and remainder, right now greatest I said least I said. We are moving to next model now it is a different model observe what question find the number which is divisible by 8 10 12 that should be divisible by 8 10 12 and lies in between of 700 and 800. The number should be divisible by 8 table, 10 table, 12 table as well as that should be divisible by 700 and 800. 700. So that means we have to, that number should be divisible by 8 table, 10 table, 12 tables. We have to get in 8 table, we have to get in 10 table, we have to get in 12 table. As well as that should be 700 800. So same first of all LCM of 8, 10, 12. LCM of 8, 10, 12. Same like earlier, what is the LCM of 120? That is divisible by 8, 10, 12 means indirectly we have to get in 120 table. We have to get in 120 table. We have to get in 120 table and that lies in between of 700 and 800. One thing that in 120 table between 700 and 120 ones 120, 122s are 240 like 12 table. 123s are 360, In 12 table, where above 70 ma? 12 6 are 72. That means 120 into 6. How much ma? 720. So what is the answer ma? 720. Okay, just ma, imagine, just think that. Just think that. First of all, find the LCM. In that LCM, ma, where? In between 700 and 800. Ma. If in case my question is in between 300 to 400, if I give 300 to 400, ma, then what is your answer ma? 120 once, 120, 122, 240, 123 ma, 360. Answer ma 360. In such a way ma. In such a way. Okay na? Right ma? Now, next ma. Once try this ma. Once try this same model ma. Try this ma. Try that. Try that. Right ma. So many people are giving ma 4032 option B, 4032 option B. Right ma. 4032 right answer ma 4032 ma. So by finding LCM ma 12, 18, 21, 32 ma. 12, 18, 21, 32 ma. LCM is 12, 18, 21, 32. We can't eliminate anyone ma. We can't eliminate. So we can Marvish ma. We can take ma 3 table. 4s, 6, 7s, 32 we can't, but we can eliminate the 4. Next ma 2 3s, 7 we can't. 2 16s. That's it ma. 3 2 just 6, 6 3 the 18, 18 sevens ma. 126 into 16 ma. How much? 2016. By multiplying ma, LCM is 2016. Now, but we require the number that lies in between 4000 and 5000. In between of 4th and 5000 ma, 2016 table, 2016 one time 2016, 2016 two times ma, 2016 into 2 means 4032. 4032. So option ma, option B, 4032. Or we can move ma one by one option ma, one by one option, which option will satisfy. But compared to option ma, it is only better for you ma. But we can go through one by one option. Which option is divisible by 12, 18, 21, 30? In that way also we can proceed. Okay now. Every option we have to check that pa, which is divisible by 12, 18, 21, 32. In that way also we can proceed. Right pa? Now, next. Now, what is the next question ma? Observe ma. If the students of a class can be grouped exactly into 6 or 8 or 10, then the minimum number of students the class must be. So I want to divide the students as a group of 6 members or 8 members or 10 members. At that time, minimum how many number of students should be? That means I want to divide as a group of 6 members or 8 or 10. That means that group of students is divisible by 6. Because I can divide by easily 6 members, or that should be divided by 8, or that should be divided by 10. That means we have to get in 6 table, we have to get in 8 table, we have to get in 10 table, we have to get in all tables. So first of all, just ma LCM. LCM is your answer. Procedure is LCM or one by one option checking ma. Which option is divisible by 6, 8 to 10? Among the options ma, least option is 60. It is divisible by clearly 6. We can divide 6 members, but we can't divide 8 members ma. 60 not suitable. 120 with 6 table divisible, with 8 table also divisible, with 10 table also divisible. So what is the answer ma? 120. 120, 121. Otherwise, my procedure is LCM. Just find the LCM, that is the procedure. Or otherwise, we can move on this way. Okay? Right. Next one. 13. Observe the 13 ma. What is 13 ma? This coin ma we learned in school maths also ma. Now 13. Four bells ring at intervals of 4, 6, 8 and 14. 4, 6, 8 and 14 seconds respectively. They start ringing simultaneously. All simultaneously means at a time. At a time. All are started at a time. At what time? 12 o'clock. At 12 o'clock, all are started. At what time will they ring again together? Will they again ring simultaneously? Okay, ma. Here, ma, 4 bells are there, ma. First bell rings for every 4 seconds. Second bell rings for every 6 seconds. Next one every 8. Next for every 14. That means, ma, it rings for every 4 seconds. That means in 4th second it will ring. Again, at what time it will ring? Next to 8th second, next to 12th, 16. It will continue in such a way. It is ma for every 6 seconds. Ma. That means next ma 12, 18, 24. In such way. Such way. Okay, it is for every 8 seconds. Ma. Next ma 16, 24, 32. Such way. It is ma for every 14 seconds ma. 14. Next ma 14 plus 14 ma 28. Next ma 42. Such way. Okay, that way continuous process going on. Question asking at what time will they again ring simultaneously? At what time all should be ring at same time? All should ring at same time. If you observe ma, in 8th second it will rings, but it will does not. It is also rings, but these two not rings. Okay ma? All should match. All should be matched. That means same. At what time? That means that number, that particular number, we have to get in 4 table, we have to get in 6 table, we have to get in 8 table, we have to get in 4 table. Now, if you take that value, 24 here, there, but here not there. If you continue, you will get 24 here. But in this table, we can't get 24. 24 is satisfying for 8, for 6, for 4. But in 14, we can't get that particular number. We have to get in 4 table, we have to get in 6 table, we have to get in 8 table, we have to get in 12 table. That means we have to get in all the tables just ma LCM. LCM. Now, what is the 4, 6, 8, 14? Can we eliminate any numbers ma? Clearly we can eliminate the 4. Take the 6, 8, 14 LCM. 2 3s, 4s, 7s. That's it. What is the LCM? 2 3s are 6, 6 4s are 24, 24 into 7 ma. 24 into 7. How much ma? 7 4 is 28. 2 balance ma 141, 68. After 168 seconds, again all will ring. After 168 seconds, 168 seconds, nothing but how many minutes? For each minute, 60 seconds. 2 minutes, 120. But it's 168. So 2 minutes extra how many seconds? 48. 2 minutes, 48 seconds. Already was given clearly time at what time? 12 o'clock. After 12 o'clock, 2 minutes, 48 seconds means 12 o'clock, 2 minutes, 48 seconds. 12 o'clock, 2 minutes, 48 seconds. Option A. Answer is option A. 12 o'clock, 2 minutes, 48 seconds. Okay, na? Here, here bells is given. Sometimes, they will give bells. Sometimes they will give traffic signals. Traffic signals. In some problems, persons are running in a circular track. Persons running in a circular track. Circular track. Circular track. Bells ringing. Traffic signals changing. Persons are running in a circular track. In all these cases, we should find the LCM only. In all this, bells ringing, persons running in a circular track, traffic signals. In all these cases, we should find the LCM for timings. For which we should find the LCM? Timings. Timings. For the LCM, we should find timings. Timings. Okay, now. Right, now. Five bells begin to toll together and toll respectively at intervals of 6, 7, 8, 9, 12 seconds. How many times? How many times they will toll together in 1 hour, excluding the one at the start? First bell rings for every 6, second bell rings for every 7, 8, 9, 12. Question: how many times they ring together? First of all, by finding the LCM, you know that at what time they will ring together. Okay, na? 6, 7, 8, 9, 12. 6, 7, 8, 9, 12. 6, 7, 8, 9, 12. Can we eliminate any number? What we can eliminate? 6. 6. For the balanced numbers, LCM. In which table we can take? Can we take 3 table? 7 we can't. 8 we can't. 3 threes. 3 fours. Can we eliminate any number? 4 we can eliminate because in 4 8 will get. Okay, na? What is the LCM? 3 sevens are 21 into 21 eights are 21 eights. How much? 168. 168 threes. 168 into 3. 168 into 3. How much? 3 eights are 24 to balance. 3 6 are 18. 20 to balance 504. After 504 seconds, they will ring together. After 504 seconds, 504 seconds, nothing but nearly how many minutes? 504 by 60. 68. 68 480. Extra how much? 24. That means 8 minutes 24 seconds. They will ring for every 8 minutes 24 seconds. For every 8 minutes 24 seconds, they will ring together. LCM 8 minutes 24 seconds. That means for every 8 minutes 24 seconds, they will ring together. Every 8 minutes 24. But question asking how many times? How many times they told together in 1 hour? Every 8 minutes 24 seconds means roughly see that how many times? 8th minute. Next 8 8 16 minute. In that way 1 hour means how many minutes? 1 hour I will show here your idea purpose. Fast is 8 minutes 24 seconds. Again, next one, 8 plus 8, 16 minutes 48 seconds. Okay. Again, 8 minutes 24, by adding 8 minutes 24 for that one, what will happen, 16 plus 8, 24. For this adding, it will 1 minute crosses, 1 minute. So 16 plus 9, 16 plus 9. 16 plus 9, how much, 25, 16 plus 25 minutes 12 seconds. 12 seconds, again if you continue that, next one, 25 plus 8, 25 plus 8, 33 minutes 36 seconds. Next, 8 minutes 24 seconds, 8 minutes 24 minutes 33 plus 8 minutes 24 means that will becomes 1 minute, totally 9 minutes. 33 plus 9, 42. Next, 42 plus 50 change you will get, next, one more is 58 change. That means how many times, 1, 2, 3, 4, 5, 6, 7 times. 7 times. Answer, 7 times. Okay, na? Here, one thing we should remember, excluding the start given. Whenever excluding the start only 7 times. If he was not specified excluding, if he not specified excluding, then we should add 1 for that. We should add. At that time, your answer is 7 plus 1, 8 times. Starting 1 means beginning time, beginning, 0th minute, 0th minute, 0th minute, okay, na? Starting 1 means beginning 1. Whenever the question is excluding, don't consider starting 1. If it's not specified excluding, then your answer is, whatever you will get, further we should add 7 plus 1, 8 times. Okay, based on the question structure, right? Now, next one. Now, what is the next question, the traffic lights at 3 different road crossings, the traffic lights at 3 different road crossings change after 24, 36, 24, 36 and 54. If they all change simultaneously at 10:15, all are changed at 10:15 a.m. Then at what time will they again change? At what time will they again change? Will they again change at what time? Okay, now I said, bells ringing, traffic signals changing, persons running in a circle. In all this we should find LCM. So take the LCM for which numbers? 24, 36, 54. 24, 36, 54. For all these, we should take the LCM, 24, 36, 54. Can we eliminate any number, We can't eliminate, We can't eliminate, So take the normal. Which table, Can we take 12 table? In 12 table we can't. 12 is not prime, but we can take, but we can't take here because in 12 table we can't get the 54. Can we take 6 table? In 6 table we are getting all, so 6, 4s, 6, 9s. Next, 2, 2s, 2, 3s, 9 we can't. 3 we can eliminate. 3 we can eliminate. So what is the LCM? 6 2s 12, 12 2s 24, 24 into 9. 24 into 9, 9, 29 is 180 plus 36, 216. After 216 seconds, they will change. After 216 seconds, 216 seconds, nothing but how much, by 60 means 63 is 180. 63 is 180 means how much extra, 36. So 3 minutes 36 seconds. 3 minutes 36. Already was given clearly, at 10:15. At 10:15, all are changed. At 10:15. So after 10:15, 3 minutes 36 seconds. After 10:15, 3 minutes 36 means 10:18 36 seconds. 10:18 36 means option B. 10:18 36 means option B. Okay, bells ringing, persons running in track, circular track, traffic. In all these cases, we should find the LCM for timings. LCM for timings. Okay, now once try this, try that. Option B 6 hours. Option B 6 hours. She'll see no. What the question is Gurma? From a point and a circular track, from a point and a circular track of 5 kilometers long. A, B, and C started running in same direction. One circular track is there. This track length is how many kilometers? 5 kilometers. Here, let us assume this point. Let us assume all are started here. All are started here. Let us assume A, B, C. All are started. All are traveling in same direction. Same direction. Right. Same time, same direction, and same time with the speeds of 2.5. First person speed 2.5 kilometer per hour. Second person speed 3 kilometer per hour. Third person speed 2 kilometer per hour. Right now, all are started at same place. They are traveling in same direction with the speeds of 2.5, 3, and 12. Then on the starting point, all three will meet again after. Again after what time? After what time they will meet at starting? After what time they will meet at the starting? What I said, when not this kind, LCM we need to LCM for the timings we should find. We don't find for this one. These are the speeds. These are the speeds. For these we should not find the LCM. LCM we should find for the timings. Timings. Okay, na? That means LCM of timings. Basically, what is the time formula? Distance by speed. Time formula, distance by speed. That means 5 by first person speed 2.5. 2.5 nothing but 5 by 2. Next 5 by second person speed 3. Next 5 by next person speed 2. 2.5 5 can becomes 2. So 2 comma 5 by 3 comma 5 by 2. Nothing, that means by 1. For these we should find LCM. LCM. Okay now. Earlier I said what is the LCM of fractions formula? LCM of numerators by HCF of denominators. LCM of numerators, that means 2, 5, 5. 2, 5, 5. What is the LCM? 10. HCF of 1, 2, 3, 1. So what is the answer? 10. Option C, not option B, option B. Okay, LCM of numerators. 2, 5, 5. LCM is how much? 10. HCF is 1. So answer is 10 hours. 10 hours. Okay, now we should find the LCM for timings. Timings. Is it clear? Right, now next. Now, what is the question? Now I said when bells ringing as well as persons running a circular track as well as traffic signals changing. Bells ringing, traffic signals changing, persons running a circular track. In all these cases, we should find for the LCM for given timings. Okay, right. We are looking for next question. Next one. Observe. 3 men step off together from a same spot. 3 members are started same spot. Their steps measures 63 centimeters, 70 centimeters, and 77 centimeters respectively. The minimum distance each should cover so that all can cover the distance in complete steps is. Let us assume 3 persons started. 3 persons. First person step distance is how many centimeters? 63. Second person step distance 70. Next person step distance 77. Right, all are started here. First person step distance is 63. Second person step distance 70. Next person step distance 77. Question: After at what distance they will cover in complete steps ma. The minimum distance each should cover so that all can cover the equal distance ma. All can cover the distance in complete steps is in first step he will cover by 63. Okay, he will cover 70, he will cover our 77 while starting all are started same spot, while starting all are started same spot, but after first step ma, they will be at different positions ma. He was at 63, he was at 70, he was 70, so all are different position ma. Question asking after minimum how much distance they will get same spot, they will get same spot. That means that number we have to get in 63 table, we have to get in 70 table, we have to get in 77 table. That means just find the LCM ma, LCM ma, 63 70 77 ma, 63 77. By looking you will get the clear idea. These all numbers in which table ma? 7 9s 10s 11s. Still any more ma? No more. What the LCM ma? 7 9s are 63, 63 tens ma? 630, 630 into 11 ma. 630 into 11, 0 33 366 16 6930. After 6930 centimeters ma, all should be in same ma, all should be in same position. Okay na, we have to get in ma, such number we have to get in 63 table, 70 table, 77 table, 77, all should match at same place, all should match at same place, equal all should cover the same distance, means complete no, all should match at same place ma. Okay na. Now Now, up to now, Visa LCM based examples. Okay, na ma? LCM based ma. First ma in LCM based ma. In LCM based, I said ma very first, when exactly divisible ma, then LCM. When leaving same remainder ma, LCM plus remainder. When leaving different remainders ma, LCM minus remainders. Okay na? And when increased by means, whenever the word increased is given ma, LCM minus that thing. When decreased is given ma, LCM plus that thing. LCM plus that thing. Okay na? When question is greatest 4 digit or greatest 5 digit ma, then with LCM we should divide the greatest number. What is the particular number ma? At that time whatever the remainder something will be there. So our answer should be greatest number minus remainder. That is your answer. Okay na? And next ma, when least 5 digit or 4 digit ma, with LCM divide the least number something remainder, then our answer should be least number plus we should add the LCM minus remainder difference. LCM minus remainder difference. This is all shown already. Okay na? And when exact LCM, when leaving same remainder LCM plus remainder, leaving different remainders LCM minus LCM minus difference. Sorry, LCM minus difference. LCM minus difference ma, when increased by word is given ma, LCM minus decrease that value, when decreased word is given ma, LCM that value ma, when greatest such kind of numbers ma, with LCM divide the greatest number, whatever the remainder ma, that remainder subtract from greatest number ma, when least number is given ma, with LCM divide the least number, whatever the remainder something you will get ma, for the least number we should add the LCM and remainder difference. Okay na, these all I told ma, one by one ma. Okay na, and as well as ma, when bells ringing, traffic signals changing, persons running in a circular track ma, in all these cases ma, we should find ma LCM of timings. LCM of bells ringing, persons running in a circular track, traffic signals, in all this we should find my LCM. These are all the thing ma I discussed one by one. Okay na? Now up to now we saw all LCM based examples. Now we are moving ma HCF based examples. Okay na? Now we are moving ma HCF based examples. HCF based examples. Now see that. What is the question ma? Find the greatest number. Find the greatest number which will divide 321, 428, 535 exactly. 321, 428, 535. We should find the greatest number. What is the greatest number? We don't know. But with that greatest, that greatest should be exactly divide these numbers. One greatest number. What is that? We don't know. With that greatest number, if you divide the 321, we require the remainder 0. Exactly means remainder 0. With that greatest number, if you divide the 428, we require remainder 0. With that greatest number, if you divide the 535, we require the remainder 0. What is such kind of greatest? What is such kind of greatest? Procedure is just we should take the HCF of 321, 428, 535. By finding the HCF, that is the answer. By finding the HCF, that is the answer. Okay, na? Greatest number that will exact divide means just we need the remainder 0. Procedure is directly take the HCF, or we can go through options. Which option will divide these numbers clearly? Among the options, what is the highest number? 109. In 109 table, can you get 321? If it is nearly 3 times, because 100 change. 109 3 is how much? 327. Not getting. So it is eliminated. Why? Because we are choosing option C. First of all, we require greatest number. Among the options, C is greatest. That's why we are moving to C. Okay, na? If C is not suitable, go for next greatest. What is next greatest number? 107. In 107, is it divisible exactly? 107 nearly how many times? 3 times. 107 3 is 3. Clear? Okay, na? Next 107 4, 428 clearly. Next 107 5. So clearly, what is the answer? 107. Option B. Option B. Okay, right? Option B is clear. Now here, whenever greatest number that will exactly divide means just to find the HCF, procedure HCF, or go through option verification. Now, what is the next question? Next, find the greater number. Find the greater number which when divides 87, 138, 87, 138, and 187. It is printing mistake, printing mistake. It is. This should be 189. Okay, that is printing mistake. That should be 189. 189, leaving a remainder of 2 in each case. Okay, it is printing mistake. 189. That should be 189. Okay, so leaving a remainder of 2 in each case. What is the question? Find the greater number. One greater number. One greater. The greater we don't know. With that greater, if we divide the 87, we require remainder 2. With the same greatest, if we divide the 138, we require remainder 2. With the same greatest, if we divide the 189, we require remainder 2. Everywhere we require remainder 2. What is the difference for the earlier and present? Earlier question exactly divides. Now we don't want exact. In every case, what is the remainder we require? 2. It may be 2, 3, it may be any number. Remainder we are getting means that is extra. That is excess is there. So first of all, subtract remainder, then take the HCF. Subtract remainder, then take the HCF. 87 minus 2, 85. 138 minus 2, 136. 189 minus 2, 187. For these, we should take HCF. Remainder getting means that is excess. Subtract the remainder and take the HCF. 85, 131. By looking, you will get the idea. These all the numbers you will get in which table? Which table? 17. 17, 5, 17, 8, 17, 1, 17 levels. Again, can you get anywhere? Nowhere. So, what is the HCF? 17. Answer ma 17. Answer 17 is clear. Okay, na? Or here I'm not options are not there, but if it is options, go through one by one options also. We can check it. We can check it by through options also. Earlier question ma exactly divide. When you're exactly divide ma, just take the HCF. Now the question ma leaving the remainder 2. Whatever the remainder ma, subtract that and then take the HCF. Subtract the remainder, then take the HCF ma. Everywhere remainder is 2 only. Okay na? Now next ma. Find the greatest number. Same ma. Find the greatest number that will divide 640, 710, 1526 so as to leave 11, 7, 9 as remainders respectively. 11, 7, 9 as remainders respectively. What is the difference ma? Previous and present question ma? Earlier question, everywhere same remainder. Now the question ma everywhere ma different reminders. Whenever different reminders ma, first of all subtract. Same logic ma, same logic, same or different, same. Whatever the reminder, that one subtract, then take the HCF ma. Subtract ma. 640 minus 11. 640 minus 11 ma. 640 minus 11 how much ma? 629. Next, 710 minus 7 ma. 710 minus 7 means ma 703. Next, 1526 minus 9. 1526 minus 9 how much ma? 1517. For this we should take the HCF. For this we should take the HCF. Okay na? Now bigger numbers ma, when bigger numbers ma we can't get the idea. In earlier only I said ma when bigger numbers ma go through option way ma, option. You'll get the idea easy. Among the options, what is the highest option ma? 42. 42 clearly even number. In 42 table, we can't get 629 odd number, that is even number. We can't get, so we can eliminate clearly. That is clearly eliminated. Eliminated. Okay. Now next, what is next highest option? 37. Check it ma 37 table ma 37 table ma 37 ones are 37 ma 37 ones are 37 means how much balance ma 37 1 37 means 40 40 means 22 25 259 will balance 259. Can you get 37 table ma? We have to get the end digit 9 ma. If it is 7 table 7 times 7 7 49 4 20. Okay, that is clear. In 37 table clearly we are getting. Now shall we check the 37 ones 37 37 ones 37 means 33 33 means 333. In 37 table, can you get ma 333? Maybe we have to get the 3 ma, so maybe 9 times. 9 7 63 6 27 30. That is also clearly 37 table ma. Now go for next 1517 ma. Are you getting in 37 table? 37 how many times ma? 4 times or 5 times ma? 5 times it will cross. 37 fours. 37 fours how much ma? 148. 148 means 3 balance 37 37 was. So clearly all we are getting in 37 table ma. All we are getting 37 table. So what else? HCF was 37. 37. Is it clear ma? Okay na? Now I said 3 ma. Exactly divides, leaving same remainder, leaving different numbers. Exactly means ma, just to take the HCF, leaving same remainder or different remainders. In both cases ma, subtract the remainder, then take the HCF. Subtract the remainder, then take the HCF. Okay na? Now next ma. Now find the greater number which when divides 65, 93, 114, leaving a same remainder in each case. Already I told about same remainder. But in earlier question, here also leaving a remainder of 2. Everywhere remainder 2. Clearly said that my remainder is 2. But in present question, leaving a same remainder, but it was not specified what is the remainder. Not specified what is the remainder. Whenever he says the same and will does not specifies, then how to approach. Okay na? So here ma 65 93 114. It is first number, it is second number, it is third number ma. HCF of difference of 1 2 2 3 3 1. Whenever leaving same remainder, and he will does not specifies what is the remainder ma, then we should take ma HCF of difference of two numbers 1 2 2 3 1 3 1 2 2 3 1 3 1. Now HCF of difference of 1 and 2 65 93 ma, 65 93 what is the difference ma, 70 23 28 28. 2 and 3 93 114 93 114 difference ma 21. 1 and 3 ma, 1 and 3 65 114 35 39 49. For these we should take the HCF ma, HCF. All you will get in which table ma, 7 7 4s 7 3 7 7. That's it. So what is HCF ma? HCF is 7 ma, 7. Is it clear ma? Okay na? Now I said ma 4 cases ma, 4 cases. When exactly ma? When exactly just HCF. When leaving same remainder, different remainder. Same remainder, different remainder ma. In both cases ma, subtract the remainder, then take the HCF. Subtract the remainder, then take the HCF. Okay? And leaving same remainder, and he will does not specify leaving same remainder, he will does not specify the remainder, then how to approach ma? HCF of difference of 1 2 2 3 1 3. For that difference we should take the HCF. That is your answer. Okay, now this model ma, let n be the greatest number that will divide 1305 4665 6905, leaving the same remainder in each case. Earlier model, leaving same remainder but not specified. The sum of the digits of in n is, so first of all same like earlier ma, same like earlier. First of all find the number. How to find the number ma? Difference of 1 2 2 3 1 3 ma, difference of 1 2 2 3 1 3. For that differences take the HCF, that is our number. But he was not asking number. In number, what is the sum of digits ma? Sum of, first of all find the number ma, then add the digits ma. Once try that ma, try that. Right ma? Now first of all shall you know ma, take the difference of two numbers ma, two numbers. 1305 4665 6905. Difference of these two ma. Difference of these two. How much ma? 5 minus 5 0. 6 minus 0 ma 6. 6 minus 3 ma 3. 4 minus 1 ma 3. First difference 3360. Next difference ma these two. 5 minus 5 ma 0. 10 minus 6 ma 4. 8 minus 6 ma 2. 6 minus 4 ma 2. 2240. And first and last difference ma. First and last difference ma. First and last difference. 5 minus 5 ma 0. 0. 9 minus 3 ma 6. 6 minus 1 ma 5. For these we should take the HCF ma. For this we should take the HCF ma. Observe ma, all numbers ma you will get in which table ma? All are ending with 0 ma. So clearly we will get in 10 table. 10 336, 10 224s, 10 560s. Okay na? Next again, if you observe carefully ma, all will get in which table ma? Can we get in 4 table ma? All last which divisible by 4, all will get in 4 table. 4 8 is 32, 1 4 4s, 4 5 is 20, 4 6, 4 1 is 4, 4 4s. Again ma, all you will get in which table ma? 7 table can you get ma? We will get in 7 table as well as ma 4 table. 7 table, 4 table, that's why we can take directly 28 table ma. 28 3s, 28 2s, 28 5s. Still we can't get anywhere, so we can stop. So what is the number ma? Number is 10 into 4 40, 48 into 28 ma. 28 into 40, 28 4 how much ma? 28 into 40 ma. 0 4 8 is 32, 3 4 2 is 8, 11. Number is 11201. Number is 1120. But question asking not the number. What is the number means 1120. Question asking the sum of the digits ma. Sum of the digits ma. Sum of the digits nothing but ma 1 plus 1 plus 2 plus 0. 1 plus 1 plus 2 plus 0. How much ma? 1 plus 1 ma 2. 2 plus 2 ma 4. So what is the answer ma? 4. Nothing but option A ma. Option A ma. Right ma? Option A. Right ma? Up to here finish ma. I will continue my next session. I will continue next session. Right ma? Thank you ma.